Mute. Okay, can you guys hear me? And somebody say okay now?
Yes.
Chat window. Hello? Can you guys hear me? Oh.
Yep, I can hear you.
All right. So can you guys see my screen one last time?
Yes.
Can somebody say yes that they can see my screen share, please?
Yes, we can see your screen.
Okay, let me try this. Stop sharing. And I'm going to restart my screen share. And this is what I'm sharing. Okay, I reshared my screen. So this is, all right. Thank you, Sophia. Sorry about this hiccup, everyone, but thank you for this opportunity. So I'm hoping to share, as I said, what I learned over the last couple of years, last 3 years, especially using drones. I have primarily used satellite images for most of my career, but I wish there was drones when I was doing my graduate school, and I would have utilized it. But once I got out, then the drones, off-the-shelf drones came out in the market, and I'm going to be sharing some of the applications that I do. So the structure of the talk would be, I'm going to share, I know the audience here, some of you are an expert and using maybe drones for quite some times, different kind of sensors, and some of you might be just getting started. So I'm going to try and hit the middle ground somewhere and try to focus on a little bit of everything in this presentation. I'm going to talk about the sensor types and US platform types that are available, a brief overview. Once you acquire the images, what are our options for data processing in terms of aerial photogrammetry? And then I'm going to be focusing on some of the applications that I have tried doing and the pros and cons and what I have learned. So I just wanted to point out that having done satellite remote sensing with Landsat, MODIS, high resolution sensors, where I find drones most interesting is if you want to monitor a relatively small area. By relatively small area, I'm not even talking about county level, a couple of thousand hectares at most, then that's where drones become very, very important, because with satellite, we don't have the required pixel size. Right now, I'm trying to map cold water streams in driftless region of Iowa and La Crosse in Wisconsin, and the highest commercial resolution that's available to me is 50 centimeter panchromatic imagery. But with drones, we are able to get down to 1 centimeter. So that's the pixel size advantage we have. Also, we are not impacted by cloudy weather. If we compare the drones to field-based surveys, they are really, really powerful. The area that you can cover based on a field-based survey, like GPSing coordinates of species and things like that, you can expedite or make that process faster of field work by integrating drone into your apparatus, and that can really be helpful to map things in much more detail, much faster. So we are not talking about replacing satellite-based remote sensing with drones at this point, because those drones are not capable of mapping, very big area. So a little bit of background on, if you want to buy your own drone, there are many different off-the-shelf drones available, and there are many different vendors that this slide is showing. And DJI is probably the biggest vendor out there. They are the market leaders, especially in quadcopters and bigger quadcopters and smaller ones. So basically, there are three different kinds of drones out there. These are quadcopters. In this slide, you can see it can range from a couple of $1,000s to several $1,000s. Of course, the smaller ones cannot take the bigger payload. So this one is coming with a 20 megapixel camera. And if you want to throw a thermal camera in there, a hyperspectral camera in there, or a full frame 40 megapixel camera in there, you'll have to buy a bigger drone, such as the Matrice 200 or 600, and that can cost you $8,000, $10,000, $15,000. But the advantage of our multi-rotors is they launch vertically, land vertically, and with the bigger ones, we can carry some bigger payloads too. Then the next step is to have a fixed wing aircraft, and the advantage of fixed wing aircraft is that the amount of ground that you will map with one single battery, say 15-20 minutes, your quadcopter will give you 120 acre. But if you have a fixed wing, it can go 500, 600, 700 acres, right? So you can map much bigger area with a single battery or same amount of time. So if we talk about this fixed wing, there are two different kinds, and here is the Trimble UX5HP. Hopefully this video will work. Let me play this. So as you can see, it takes a lot of space to launch and land. You just cannot use this in closed canopy areas, but it flies much faster. It can take much bigger size of or heavier payload. And of course, it's more expensive. And perhaps an amalgamation of both a fixed wing aircraft and a quadcopter or multi-rotor is what we call the vertical takeoff and landing drone. And these drones actually can take off and land vertically, but once they reach a flight elevation, they change from what for Firefly 6 we call from hover mode to forward flight mode. And in forward flight mode, it flies like a fixed wing. And then when the flight is done, it can come back and switch from that forward flight mode back to hover mode and land vertically. So there are a couple of off-the-shelf VTOLs available. Here's the Firefly 6, and there is one that is Wingtrap. And more recently, there's this company called Alti, and this is really mind-blowing because some of their platform can fly for 8-hour, 10-hour, 20-hour, and you can see this field is evolving so much the information that I'm giving you probably already old, and there are longer endurances VTOLs available. But again, to fly them legally, of course, you won't be flying in the US without FAA's permission, out of line of sight or beyond sunset. So we have to follow those rules, but definitely these options are there that can fly much longer, like 8-hour and 10-hour. I can't think of an application right now where a geographer, remote sensor like me will want to fly a VTOL for 10 hours. It's going to generate enormous amount of data, and then data handling and processing would be an issue. But nevertheless, this is an option that's out there. So here's a video of our vertical takeoff and landing, and this is the Firefly 6 Pro, and it's fitted with a Red Edge MX camera, and we were using this to map prairie vegetation. So as you can see, it's launching vertically, and once it reaches, I think 50 meter was the elevation where we said, okay, switch to forward flight. So it goes like a fixed plane and then coming back. So that's our 3 different kinds of drone, mechanically speaking. that are available. The bigger ones can take bigger payloads and map much larger area in the same amount of time. So the next thing is I have a drone, but how do I fly it? Most of these drones, they use mission planning apps, and there are mission planning apps which are freely available, like Pix4D Capture, or you can have Map Pilot. And so those are for smaller quadcopters, but for bigger VTOLs like the Firefly 6 Pro, most of these companies, they design their own software and they provide you with their mission planning software, and there is a little bit of learning curve here, but it's not that bad. There are online tutorials. So if we have a Trimble fixed wing, you need to learn their interface, how to fly it. It comes with a tablet, and when we jump to Firefly 6 Pro, we need to learn their interface. But these are not that difficult to learn. You just have to spend a little bit of time. And recently, I've found out that there are, mission planning apps which are available for a couple of $100s, which can fly multiple different kinds of aircrafts. So those are also out there, but I have not experimented with them. So yeah, in these mission planning apps, you basically define how big an area do you want, what speed do you want the aircraft to fly, what's the overlap, and it calculates all the necessary parameter, takes you to the amount of acres it's going to map, how many photos it's going to take, and the ground resolution, roughly 2 centimeters in this case, that we will be getting. In this case, you can see this area is on the Mississippi Channel, and you can see this is showing the boundary for the La Crosse Airport, which is, I think, class restricted airspace. It's definitely not class G. So we were fine. We were just flying outside that. But again, this VTOL we have, Firefly 6 Pro, it flies for about 45 minutes, 40 minutes, and this would require 2 batteries. So not very difficult. And the last thing probably is, once you have the aircraft, once you have the mission planning app, what camera or what payload do you want to fly? And that's a big question that you have to ask when you're trying to buy your drone. Is it that you're going to monitor vegetation with it? Are you going to monitor vegetation radiometrically, or you just want the structure of vegetation? Or do you want to map temperature? Or do you want to map just how many trees do you have? Or do you need to distinguish species, right? So if you want to map vegetation radiometrically, you need to have ideally have a radiometrically calibrated camera. If you just want to map the geometry, the height and density of vegetation, then radiometric calibration is not important. You can probably do that with a normal RGB camera, so on and so forth. Choices of US platform and camera. Here is what we call a hyperspectral camera, which is from a company called Headwall Photonics. This can help you identify plants at species level, but it costs a lot. There are more cheaper multispectral options, such as Red Edge MX from MicaSense, and then we have Red Edge MX, and we have this Sequoia also, and they came out with an Altum sensor, wherein they are now integrating their multispectral with thermal, all of it low resolution thermal sensors. So lots of options out there. And of course, at the more higher end, if you're interested in mapping vegetation in 3D or 3D structural features, then there's nothing better than having a LiDAR sensor. But again, you need to have bigger platforms that can take these LiDAR sensors. And of course, it depends on your budget, because these sensors are also not cheap. But with LiDAR, drone photogrammetry or structure from motion is called poor man's LiDAR, because with overlapping photos, you can generate something like this. What we can't see in our photos, we can't have a point or coordinate point for that. So this is what we get from structure from motion or drone photogrammetry. We get the canopies and the top of the canopies, but since we are not able to see what's underneath the canopy, we don't have a measurement of underneath the canopy. Whereas when we have a LiDAR sensor on a drone, we can see that LiDAR can penetrate canopy significantly, so we do get the actual 3D vegetation structure. Nonetheless, what people have been trying to do is fly drones at multiple angles for the same area. So if you're looking vertically down here, that's why maybe you're not able to get points here. But if your camera is inclined at 60 or 70 degrees, then you might have some shot of getting some kind of photos here, which can then be photogrammetrically processed and transformed into a point cloud. So while LiDAR can provide more detail underneath denser vegetation, both photogrammetry and LiDAR can generate terrain models underneath sparse vegetation where the ground is partially visible from here. So vegetation density is a challenge. If you are working in an area where vegetation is very dense, then probably you will not get a good, what we call digital terrain model from structure from motion photogrammetry. You will need some LiDAR data for that. So choosing the right drone and the sensor, the first thing you have to ask is what kind of application I'll be doing, and let that drive the decision as to which drone and camera will you buy. Spend twice as much time choosing the sensor package as you are for the bird. So can the platform carry different types of sensors? So one of the mistakes I would say I did 4 or 5 years ago is I bought the Trimble fixed wing sensor, and lots of Trimble fixed wing aircraft, and lots of the sensors that are coming out, they are not compatible with the Trimble product. So buy a platform that can take many different kind of sensors, that can integrate many different kinds of sensors. That's the lessons that I have learned. And yeah, budget is of course important. So you have the sensor and you have the platform, you have the mission planning apps. You flew the drone, we collected a lot of data, and now what do we do and how do we process the imagery? So there are data processing softwares available, and I primarily work with, again, commercial vendors, and these are some of the vendors that I know exist. Well, Edgysoft has now become Metashape, and I use Pix4D extensively, and I'm happy with their performance. And I've tried to compare Pix4D with Edgysoft and Metashape, and I don't see any significant difference in their quality of output, either geometric accuracy wise or looking at the Ortho Mosaic quality wise, visual quality wise. I don't find any significant difference. But I have not tried like drone deploy or drone to map or all these softwares. But having done some literature review, I can say that there are free and open source softwares also available, but I don't know how easy they are to use. So once we get the images from the drone and we start processing with these softwares, here is what we get. We get what we call a 2D Ortho Mosaic. Here basically in layman's term, you can say that all the individual overlapping images are kind of mosaic together to create, and it's a mosaic which is corrected for perspective. So this is actually a map, and we can make measurement like how big is that roof of the building, and shape and size of things will be very highly accurately calculated with the Ortho Mosaic. because you can see this is 1 centimeter pixel size. So we get a 2D Ortho Mosaic from our structure from motion processing. The second thing we get is what we call, what Pix4D calls a ray cloud, but this is essentially a point cloud. Remember, this is the point cloud that you get also from LiDAR, but again, we don't have what we see underneath the canopy because we are not able to penetrate the canopy. So also what the software, most of these softwares are doing is they're taking these 3D point clouds and they're rasterizing it as a DEM or digital surface models. And so you also get this 3D representation. So we get an Ortho Mosaic, we get a point cloud, and we get a digital surface model or digital elevation model from our drone structure from motion photogrammetry. Also, if you were using a near infrared camera or modified infrared camera or a thermal camera, then you can produce what we call radiometrically calibrated reflectance imagery or vegetation index imagery, such as normalized difference vegetation index, NDVI. And if it was a thermal imagery, then you can probably create an orthomosaic of surface temperature. So these are the options that we have in terms of output. Now, in terms of doing science or problem solving, what we do with this kind of outputs is where the actual fun really begins for me. So I would like to divide this part of the talk wherein either we can measure geometry, shape, and structure of features and how they are changing, or we can use the radiometric properties and reflectance and say vegetation index or temperature to do some science or analysis. And what I have found is drone photogrammetry, structure from motion photogrammetry, has tremendous potential for measuring the geometry, structure, shape, and size of feature and how it's changing. Whereas the radiometric part is, according to my understanding, is much more challenging. So I am interested in physical geography related, geomorphology, fluvial geomorphology related applications of drone imagery or orthomosaic. Here in this case, you can see this is an orthomosaic, and just because the orthomosaic is 1 or 2 or 3 centimeter in size, we can see things depending on if you want to map grain size or you are mapping that small vegetation patches in a river channel or sediment transport. You can map these things for one time, even if you generate an orthomosaic and the spatial pattern in them very, very accurately. But if you did your photogrammetric drone survey for more than once, twice, or thrice, then what we do is we can detect change. So geomorphic change detection, here you can see what we call old DEM one year ago, digital elevation model. We can take a new DEM and we can just subtract the two and generate something called DEM of difference. So this has been done in many different studies to subtract 2DEM and derive digital DEM of difference to understand whether either the river is depositing or where it's eroding and what's the total sediment budget of the river. This kind of application, geomorphic change based on drone photogrammetry, can be done with if you are in a coastal area and you are trying to monitor coastal erosion. Very high potential, very accurately you can measure these things. What I am interested in is I'm interested in glaciological applications. So I've been working in Nepal with my students, and one of the challenges is understanding the response of these glaciers to climate change. So although we have been monitoring this glacier with satellite remote sensing, where drone photogrammetry comes in, as you can see, this is a high resolution satellite image from, there's a new satellite, Dove, from the Planet company, and it's 3-meter imagery, but we don't see much detail in 3-meter imagery. But if we see this in drone imagery, Ortho Mosaic, we have 3 centimeter pixel size, we see that's an ice cliff. And ice cliffs are actually very, very important because even though they occupy only 4 to 5% of the glacier, they generate as much as 30 to 40% of the melt. So if we fly this, and not only that, this is on Ortho Mosaic, but if we look at the point cloud, then we can see that this is how it's actually looking in 3D. So if we do this survey twice, for example, this area was surveyed twice, in a little bit more application with, you can see this is the quadcopter we're using. We flew almost up to 16,500 feet here. That was very challenging to collect data in this terrain, but in this overlaying area, we can measure how fast the glacier is moving between like May 2019 and November 2019. And then we can also do what we call the DEM differencing. But this is how the DEM differencing works. It's looking vertically down, comparing May to November. And if I plot the altitude change profile for this line here, cross section here, this is how it looks like. Now, what I've learned is there's something called point cloud differencing. So if you recall the point cloud, which is actually used to generate the DEM, so you're basically, point cloud is a lot of data, and you're simplifying things and rasterizing it to create a DEM. And you do that, of course, there is some data fidelity that is being lost, data quality is being compromised as you try to generate a actual 3D point cloud and then simplify into DEM. And for this area, if we were trying to compare how much the glacier is melting, and we found out that for these steep cliff areas, you can see this one is what we call the line. The DEM differencing is actually overestimating the melt compared to point cloud differencing. So the M3C2 algorithm or tool is freely available. So my big learning from this exercise is that for steep terrain areas, for steep sloping areas, DEM differencing may not be very accurate, and we have to actually do point cloud differencing. So jumping from that geometric application, if we come to the radiometric side of it, wherein we can talk about reflectance, vegetation index, and temperature, which is actually the radiometric component, not the shape and size of things, then in that respect, I have done some applications wherein we were trying to map this invasive species purple loosestrife in and around La Crosse wetlands. And this is how it looks like when we fly the drone at 20 meters, the purple loosestrife. It actually flowers in the month of July and August. So that's the only time you can see the flowers of loosestrife, and you can distinguish it from other green vegetation. So important to collect data at one particular time of the year. And if we zoom in, this is how it looks like. And we did this exercise for this area called Bryce Prairie because the Bryce Prairie Conservation Association was interested in doing some biocontrol, beetle release. So we flew the drone before the beetles were released and after the beetles were released, and tried to understand, are the beetles really doing any good? Are they really destroying it or not? So we can see that that's the area we mapped, and then we did manual interpretation, and we could map the total area and how much area was infested with loosestrife. We can calculate that, and very accurate when you're doing manual interpretation. It's relatively straightforward, but it's time consuming. It cannot be scalable over a large area. So our next goal was to, can we automate the process? Can we use a machine learning technique to automate the process? And so we were using something called object-based image analysis, and with a machine learning pipeline to actually semi-automatically detect those loose stripe patches. And in this case, if you're wondering what is object-based image analysis, this is a near-infrared imagery of the UWL campus. And this is all pixels, but when we merge similar looking pixels together, they become objects, and these are objects, and these are the object boundaries. Now you can take one whole object, for example, this whole thing is one object, and you can classify this as loose stripe or not loose stripe. And we tried this in a neighboring area called the La Crosse River Delta. If you can see, these are big patches of loose stripe. These are big patches of loose stripe here. So we're using the Sequoia sensor, which is a radiometrically calibrated camera. And this is how the imagery looks like. And this fluorescent color, these are our loose stripe patches. And we used convolutional neural networks to try and automatically identify them. But we tried a couple of things, but still there are a lot of false positive. And overall, our accuracy is still below 60%. So this is a work in progress. We're now trying on the Google's platform for machine learning and try and see if we can improve the accuracy. But if we try the same object-based image analysis classification for a different kind of vegetation, say shrubs and trees along the tree line, in this case in Nepal, about 15,000 feet of elevation, our accuracy was pretty good, 84% accuracy. So these shrubs and trees have particular geometric shape, as you can see, and these loose stripes that we are talking about, they don't have a particular geometric shape, and it's kind of hard to identify these. So this cannot be easily distinguished just based on structure or near infrared reflectance from this vegetation. So that was a big learning outcome. Also, if it's windy, the plant will shake. So you want to be flying in conditions which are clear and calm. Sun angle doesn't change very much. Flying low gives you good images, but that can use to visually interpret it to determine presence as absence. Now, if you use cheaper camera like DJI Phantom and Mavic 2 Pro, they have global shutters. They have rolling shutters actually, versus some other more sophisticated cameras have global shutters. So don't use cameras with rolling shutters because they are not good for radiometrically generating accurate images for this kind of species mapping level applications. If we fly low, USP should not be more than 4 meters. So we experimented with height and the spatial resolution that we were getting. And if you fly higher, you can fly at a speed of 6-7 meters. If you're flying low, then there is a bigger chance then the plant will move tiny bit, and because your pixel is bigger, that movement will be recorded and it will show as a blurred imagery. But if you fly high, then you can fly a little bit faster, and then even if the plant moves, it will not impact the radiometric accuracy of your imagery. So little bit of I want to show you some stuff as I work with deep learning, starting to work with it. I've been doing literature review, and what I'm finding is if the object, in this case, this big bat they're using, they're able to identify it with their convolutional neural network pretty accurately. So somebody manually interpreting it matches with well with uh, your deep learning or on a CNN-based approach. So their accuracy is pretty similar because this thing has a particular geometric shape, whereas my loose stripe canopy doesn't have a particular geometric shape, and that's why my algorithm is struggling. Similarly, you can see colonies of albatross and in the East Coast, and all of these features have particular geometric shape, and so the algorithm performs pretty well. This is a Ortho Mosaic of UAV derived Ortho Mosaic, pretty big area, and ultimately where it confuses at the shaded area or some rocks, which actually looks like the albatross. But overall, if this is something that has a geometric shape to it, think about a coconut tree or palm tree, that could be more easily detected in orthomosaic rather than a canopy which doesn't have a shape to it. I found this news that somebody crashed their drone and in California, and thousands and hundreds and thousands of birds that just left their colony because of the drone crash. So managers are hoping the bird relocate to other nesting sites, but this is something that we have to be careful about. I work with the U.S. Fish and Wildlife here in town, and one of the questions that I always get is, hey, if you fly low, this is their nesting season, breeding season, are they going to be disturbed? And what my experience is, as long as I'm above 50-meter, legally we can fly till 90-meter. They don't even get bothered. They don't even notice that something is flying. But don't know how much time I have, but I'll quickly run through some more projects that I'm doing. Vegetation phenology monitoring. If you know vegetation phenology, greening up with vegetation and dying down, and if in October, November right now. So with changing vegetation phenology, we can see how it's a cue to how the climate is impacting our ecosystem. So with the drone, if we fly a drone multiple times, like in this case, we selected a prairie site and we flew there 8 or 9 times during the spring season. And our objective here is to see species specific differences in which species is greening up first, which is greening up last, and mapping the total length of growing season. And this is how the property looks in March, and this is in May, and this is in June. So once we have this kind of data, we can do some field work to identify what species we are looking at, and then we can crop out these pixels, like this is a big blue stem, and we can calculate some spectral indices such as the green chromatic coordinate, which just tells us, how much green that canopy is. And we can apply curve fitting to it to determine these, what we call a phenophase transition date. When did it reach the greenness? When was the mid time of greenness curve? So if we do that for each individual species, we will be able to derive, oh, look at this species. This species started greening at the date of the year 140, but other one started at date of the year 160. So this is again an ongoing project here. Yeah, a little bit of more literature review, but I think I'm running out of time. I primarily
You're
work
good. You
with
have
infrared
until
camera and
noon.
RGB camera. I don't have any LiDAR sensors, but people can integrate this near infrared, RGB, and LiDAR. LiDAR will give you 3D, the real 3D, and then you can individually start detecting individual canopies, and the multispectral will help you identify different species. So there is potential. Also, if you're interested in mapping small vegetation like pioneer, production grassland, natural grassland, reed, and how their height changes over time, just with RGB drone photogrammetry, we can derive point cloud, and we can start looking at, okay, the height of this kind of vegetation is this. You have to set up ground height, which would be sometime in March. You can do This is an example from the Netherlands, and this is something we are starting to do in the floodplain here in Mississippi. So conclusion, we can collect more data over large areas effectively, not as large as satellite images, but we are not limited by clouds per se. We can generate 3D point cloud, and in the canopy areas. One of the challenges that I'm facing is I want to generate biomass maps, and for biomass, the height of the vegetation is important. Biomass map for grassy vegetation, shrubby vegetation, and with the drone photogrammetry derived point cloud, the filtering is not working very properly. So the DTM that is being generated is not actually representative of the ground. So that is one challenge. If you cannot find the ground very accurately with your structure from ocean photogrammetry, then you cannot do the vegetation height. But for trees and bigger shrubs, it's not a problem. You can find individual trees, count the number of trees, derive tree height, a canopy diameter, all of those things are possible. But if you have LiDAR and hyperspectral imagery, then sky is the limit. You can do a lot of species level mapping, and the price of LiDARs and hyperspectral sensors is slowly coming cheaper and cheaper. So they're becoming more affordable than they were 5 years ago, and hopefully we'll be able to buy one here. So I think I'll thank you for your patience. I will acknowledge lots of people here who have helped me in the last 2, 3, 4 years here in Wisconsin and in Nepal, and I can take any questions. Thank you.
Thank you so much for presenting. That was a great presentation and showing the different applications that you can use UA as remote sensing. I just wanted to double check, is everyone able to hear Dr. Mishra?
I'm going to chime in. Yes, I'm hearing just fine.
Okay, just making sure. I think Dr. Mishra, are you able to hear us okay? Let me see.
Don't see any questions.
I'm not sure if you're able to hear me. I think we're having some mic problems. But if anyone
I cannot hear you, Sophie. Let me see.
But if anyone has questions, please type them in the chat. He may be able to see those and respond.
Yeah.
But I know I do have a couple questions. Dr. Mishra has done multiple UAV flights internationally. So that is something.
I can hear you now, Sophie.
Can you? Okay, wonderful. So if anyone has questions, please ask them in chat or your mic. I do have a couple questions, but I will wait to see if anyone else has any questions. And then thank you. I'm not sure if you heard me say that, but thank you very much.
Oh yeah, thanks.
Hi, Clint. Go ahead. You're welcome to ask your question.
Hi. Thanks for the presentation. One area that you hit on, kind of a structure for motion versus LiDAR in drone work. I was wondering if I could get your perspective on that. related to coastal oblique imagery, especially if you're looking for areas where you may have clay slope or bluff erosion. Not heavily vegetated slopes, so I didn't know, but just wanted your perspective on structure for motion versus LiDAR in that aspect.
Right, great question. Thank you. So I think you raised a very good point. Not a lot of canopy. If there is not a lot of canopy, then I think the drone, which is kind of a poor man's LiDAR, will do a very good job in terms of geomorphic change detection, erosion rates, deposition rates. That's what my experience is with mapping glaciated landscape. In terms of melt magnitude, I'm within plus minus 2-3 centimeters of accuracy with my differential GNSS setup. So if there is no vegetation, then, or a little bit of vegetation, then your drone photogrammetry or structure from motion derived change will give you as good a result as your LiDAR data. I don't think there will be a need to invest in LiDAR in that case, but we do need some ground control. So ground control points needs to be established. And did I answer your question?
Yes, thank you.
And to add to that, I would say that where I kind of see in driftless area, we have rivers and streams which are under a thick canopy at times, and not only trees, but there is shrub and other kind of vegetation. And one of the things that folks here are interested in are the controls or the measures to. We have some very devastating floods in recent years, so there are stream reaches which they invested several $100,000 to restore these stream reaches over the last 10 years, and they wanted to know if the restoration work is actually successful. Is it working? So what we did was we fly the drone before the restoration work was conducted here in Coon Valley, and once the restoration work started, to see if the vegetation is growing more, if the flow is low, if there's deposition. But all of this with drone requires that you be able to detect the actual ground. And with our drone photogrammetry, the vegetation, especially smaller ones, is a big challenge that we are not able to penetrate the vegetation. And one thing that I'm trying now is acquiring images from multiple angles and see if that increases our chance of detecting the ground in dense canopy areas. So if the vegetation is a problem, or if vegetation is there, then definitely we need something like LiDAR. Yep. But that's going to cost more money, a lot of money for LiDAR.
Are there any other questions? If not, then I will ask one of them. I know you've done extensive work internationally. What is it like, or what's your biggest challenge when you're traveling with your equipment internationally? And how do you make sure that you can safely travel without, anything being confiscated?
Yeah, that's a good question. So I would say it varies depending on the region you are traveling. I know my collaborators work in Peru and they map glaciers and high elevation areas, and there's a very streamlined process of applying for drone permit, and there's kind of no corruption. That's what I know. I've never been there, but they don't have any problem. But for me, like in Nepal, so far I have not been able to take my fixed wing or VTOL to Nepal, because for the VTOL, it was total camera, and the drone was $15,000. And when I tried to ask them that, can I take this in? They said you will have to deposit $15,000.
Dr. Mishra, I think your mic just cut out. We caught everything up until the last about 5 seconds. Not yet, so I'm not sure if you turn off and back on again, if maybe that'll help.
Can you hear me now?
Yes.
All right. So yeah, I was saying that in Nepal, they asked me to deposit the value of drone as I arrived in the country, and they said they will reimburse me. And of course, that's a no-no. And then again, so we have flown Phantom 4, we have flown Mavic 2 Pro, and the just like I may go to Nepal since COVID is over in June, and the paperwork is extensive. There are 5 different ministries you have to apply to, and it takes time to get approval. So we will probably start in February or January early to get that approval done. But yeah, it's challenging, definitely, compared to, and just I was like, yeah, we can do Firefly 6 Pro, and we don't have to fly for 3 days, 4 days to map this area. We can get mapping done because Firefly 6 Pro now has the terrain follow capability. So as the terrain changes, the elevation difference between where the drone is and where the ground is can be compensated. But I reached out to Firefly 6 Pro, and they told me that they do not recommend flying at 14,000 feet. If something happens, then they will not be, responsible, or this is something that they have not tested their drone. But if you look at Mavic 2 Pro, on the website in DJI, they say don't fly it below, 10 degree Fahrenheit, and I have flown it at 0 degree Fahrenheit. They say don't fly it at above 18,000 feet, and I have flown that at Everest Base Camp at 21,000 feet. So I bet I can bet some money that the Firefly 6 Flow will fly, and it's just, yeah, paperwork. It takes time and energy, and it varies. I know my colleague here, Dr. Belby, he was interested in doing some work in Belize, and their process was pretty streamlined as to how to apply for drone permit. Did I answer your question? So
Yes, thank you.
I see a question. Where do you see the direction of drones and sensors? Will every GIS shop have a drone? Yeah, that's a big, I'm not sure, but they will become, the number of drones will increase for sure, and they will become cheaper. And I can say that right now, even in underdeveloped countries, they are talking about it, like in countries in Africa, like in Nepal, they don't have access to it, whereas most of the developed countries, like you fly a drone here, I fly a drone here in my campus, and there are like 500 students walking. Nobody even looks at it. It's like, yeah, whatever, it's a drone. But you go to a remote village in Peru and you show this to the kids, and they're like, wow, this is really cool. And so yeah, I think it will be more accessible, and there will be more interesting areas that they will be applied to. Sensors will become cheap as time progresses, but I think we will be, it's just democratizing spatial data more, and as it's becoming as drone and the data processing, computers are becoming faster, so anybody can make a problem map of their property or something they're interested in. So that is actually very good for geography in a way. So that's my 2 cents. I don't know the larger trend as to what the new sensors would be like and what the drone platforms that their endurance is already becoming very, very long. And it's just, I hope people don't start misusing this technology and follow the rules, because all you need is a one bad apple, and then it's like, yeah, everybody who flies drones is not following the rules. Yeah, I apologize, Sophia. I have a class in 2 minutes.
No problem.
So,
Thank you so much. I guess
yeah, I would say that I can write here my email. Anybody who wants to ask me a question, please email me. And of course, I don't have all the knowledge. I have a little bit of knowledge. So I would like to answer any questions that I can over email.
Absolutely. And thank you again for presenting. Please tell your class hello, and everyone in the geography department. And Dr. Gargi, of course, tell her hello. Well, thank you again. I think we'll leave you to your class. And yes, if anyone has any more questions, please connect Dr. Mishra via email that is linked in the chat. And thank you again. We really appreciate it.
Yeah, thank you so much. And good luck with everything. Thanks, everyone. Bye.
Bye.